All right, y'all, I'm ready to get started. Are you? Awesome. Hope you all had a great lunch. It's great to be here at RVAsec and great to see people in person for the first time in a long time, it feels like, at a security conference for me. I am speaking here today. My talk is called Zero Trust, the Good Parts. And it's really kind of a talk about the 3 years of work, the last 3 years of my job, completely changing how we do identity and access management at Cloudflare, and kind of building a product to offer the same thing that we use internally, externally, and all the hairy decisions and things that we had to do, and sharing the thought process throughout about how we addressed all of the problems that came with completely changing our identity and access management architecture. Who's heard the buzzword Zero Trust? A lot of hands. Whose company is seriously investing in Zero Trust and moving towards that model? Not as many hands. That's surprising. All right, well, I'll get started. So about me, I work at Cloudflare. I'm a director of security engineering there. I joined the company in 2015 as the first security engineer when we were about 100 people, and now it's been a wild ride. We're like 2,500 people about, and publicly traded, and it's been fun. Lots of security incidents in the process, and not fun times too. I also was the first security engineer at a company called Segment, which got acquired by Twilio. Before that, I was at LastPass, the password manager, and then before that, I was at JMU Double Duke, go Dukes. And I love startups and security. If you're in the startup world, feel free to ask me questions. But I have 2 cats, flew here from Texas this week, and a lot of tabs open. This is my 4th caffeinated beverage, so I'm on my way to 6. Cloudflare, if you're unfamiliar, we are a large network. We have millions of internet properties that we protect sitting behind our network. We provide like WAF solutions, DDoS mitigation, load balancing, content delivery, image optimization. Our product list is really, really long, but lots of traffic, lots of requests, real-time communication. One metric that we report on publicly is number of cyber threats blocked each day for varying levels of cyber threat, everything from a WAF event firing to like a packet blocked in a DDoS attack or something. And kind of our big thing about our network is we're all over the place. We have 250 plus points of presence around the globe doing all of these features in each one of them. Each point of presence is, we try to get it near population centers, so like this is actually more of a population graph than it is a Cloudflare network map, because we're within 50 milliseconds of like most of the planet. So it's pretty cool, really large network, hardware all over the place. And the basics of how the product and how our architecture is, and this is very important for like how we designed our Zero Trust stuff to solve for our own problems, is we sit in the middle between websites and people using them. So it makes it really easy to block stuff. It makes it really easy to do whatever we need to do. So at its core, all Cloudflare is a giant man in the middle that you actually want, rather than one that you don't want. Okay, so our strategy, this is when we get into the Zero Trust. So 4 years ago, we're sitting there and we didn't like what we had for our identity and access management. The traditional perimeter security model, the VPN, more on that later. But the whole way that we go about building security products and offering them is, I think, somewhat unique, where we build the product for us and solve a real problem, and we actually use it, incorporate it into our security model, kind of shave off the rough edges and work on it, keep iterating, and eventually someone will buy it from us. So eventually people want to use it. That strategy is called dog fooding. hence the can of Alpo. We had a VP of engineering who literally had cans of Alpo on his desk and would hand them out when people would dog food. And so I don't go a day without talking about dog fooding. It's a big deal to us. The other big part of our strategy, you can get an MBA just reading this one book by Clay Christensen, The Innovator's Dilemma. That's the other big thing to call out. Every decision the company makes, it's about like disrupting and moving into new spaces and constantly not settling for what we were doing prior. So dog fooding, huge proponent of it. I love it. And also it gives me as a security person a lot of power, because a security person at a security company where we're trying to solve our security problems with our own products, I can go to any product manager and say, hey, this is what I need. I get to set your roadmap for the next year. This is great. And so we're kind of in the middle of the product life cycle, and we feel less like a cost center and more like a value add to the business, which is unique, and it's a lot of fun. It's empowering. Okay, so we set the stage. This is a stock photo that I had in my template of a woman who looked very confused, and I think she's confused about what zero trust actually is. At least that's what I imagined. I thought about it for a while, and I tried to boil it down into one sentence about what is zero trust, and I think this is what I came up with. Feel free to raise your hand and tell me otherwise if you think differently. But I think all zero trust is you don't have an inherent trust of any other thing based on its network position or based on its IP address. So just because it's on your LAN doesn't mean you have to trust it. And I think that's, if I had to summarize in a sentence, what it is. Any other thoughts on that? Okay, we're completely in agreement on that. Cool. Cool. You can think about it and let me know if you decide otherwise. So I think the reason why we got there is because it used to be that you had all of your stuff on one network, and then I think the big thing that changed was such a huge reliance on cloud services. That's a big one. So your stuff is not just your network anymore, and suddenly there's all of these holes that you're poking in your firewalls and all of these trust relationships you have between AWS or Oracle Cloud or whoever your cloud vendors are. The advent of DevOps and containers, I think, is a big reason too, because people stopped kind of hand-making their infrastructure. It's a lot less common to see people building systems where they go run apt-get install Apache and set it up by hand and then maintain it by hand. They use configuration management tools, and none of that is based on IP. So it's all like, what's the word? All of that is done with like orchestration software to run your containers, run your jobs, configuration manage your fleet. One thing that I think is, at least for us, one of the forcing functions away from the traditional security vendors and tools was we wanted stronger second factor. I'll get into this more, but we didn't like having to use Authy and Google Authenticator as things that we relied on, and it was really uncomfortable having to settle for TOTP or whatever second factor we had available to us in some of these older tools. We wanted WebAuthn and YubiKeys and security keys, and I'll talk about that more in a bit about how we kind of made that jump. And then web-based everything. The world is on HTTP2 and HTTP now. Everything is a web service. It's less about running FTP. You have Dropbox and Drive.
What is cattle not pets?
Cattle, not pets. Yeah. So this is the idea in DevOps where you're not hand making your machine, apt-get install Apache, and let me migrate or let me rotate the logs by hand. That's a pet because you're loving that server and like taking care of just that one server. But cattle, you're treating your fleet of machines as a thing, and you solve problems for all of the machines rather than one at a time. Yeah, that's a good saying. If I have other things like that, feel free to raise your hand, jump in, ask questions. Okay, so about maybe 2016, what year is it? 5 years ago, the BeyondCorp papers came out from Google. cloud.google.com/BeyondCorp. Anyone who's seriously considering working on any zero trust products, anyone who's seriously considering a vendor to purchase zero trusty stuff, whatever you're doing with zero trust, go read these papers. It takes about 2 hours. There's 6 papers. Each one is about 3 pages. And it kind of gives you everything you need to know about zero trust before it was called zero trust. Google really built this whole thing, and like everything Google, they're always 10 years ahead of the rest of the industry because they just have so much money to throw at problems. And so they were very far ahead and described this really great kind of situation where they dissolved their network boundary. And they used to brag, here's our internal Google page, and they like posted a URL that you could just go to and be like, oh, this is like Google Corp. I could just log in if I had a password. That was a big deal. A lot of people wanted to mimic that, and it kind of set the whole industry towards this direction. You couldn't just buy it though. You couldn't just buy the BeyondCorp product. They didn't offer it at the time, and now you can kind of buy some of it from Google. Like you can buy an identity-aware proxy, but you can't buy the whole thing. So. There we are, sitting on the left. We had the security model from the left-hand side, where perimeter security model, walls, cameras, mostly security at the perimeter, and we wanted security throughout at every stage. And the very first way that we started to work on this and started to address this is we wanted to solve for HTTP. So this is solving for the web scenario. So you go to a website that we had internally, and the previous state is you had to go log into the VPN. So let's say our internal Jira or internal task tracker. You had to log into the VPN, like do the second factor thing, and then wait for the whole like negotiation of your new network, and maybe sometimes it wouldn't work. And then you could go to Jira, and then maybe an hour later you'd get signed out of the VPN, something wrong would happen. And so we wanted to first solve for that problem. And the very first thing that we did was we wrote this piece of software, which is actually so old that it's archived now on GitHub, but you can go see it and find it. And this was the original identity-aware proxy that we built. There's a lot of other prior art in identity-aware proxies. You can go look at the Bitly OAuth proxy, which is a big open source project. Google has an identity-aware proxy built into Google Cloud. There's a few others. But this was a game changer internally at our company because, well, the previous state, we had people, we run a 24/7, 365 business, and so people would get woken up in the middle of the night, and they couldn't just see what's broken on their phone. They'd get paged that something's broken. They would have to like sleep next to their laptop and then open their laptop and log into the VPN, go through that whole process I just described. So it was really, we put maybe just the metrics server, our internal task tracker. We put a few basic things behind the identity-aware proxy just to try it out with unsensitive things, because we didn't want to put everything behind it too quickly and have a security problem that we didn't expect. So we kind of went slow and started with just a few things to make people's lives easier. And it was a real game changer. the product manager for the Zero Trust stuff likes to tell the story about how they paved roads in Texas, how I'm from Texas now, I guess, but I didn't know this story. He said that all the roads were unpaved and there's so much land in Texas that they used to just pave a mile in the center of the town, and then everybody would be driving their F-150s and then hit the paved road and be like, that was awesome. I want that everywhere. And then the next election, when it was budget time, everybody wanted the paved roads, and it was really easy to get buy-in. So we did the exact same strategy as the Texas paved roads problem. And we paved just a few roads, the metrics, the internal task tracker, and it made everybody's lives easier, and everybody could immediately see the value of what we were trying to do. And so that is, you can go see this, github.com/cloudflare/nginx Google OAuth. And architecturally, this is kind of how it worked. So user, one of our operations or SRE team members, they're on the left with their laptop, just woken up at 2 in the morning because something's down. They log into, on the far right, Jira or our metrics dashboards to see what's broken. That passes through our network, and when our network sees the request going to that particular URL, they say, hey, this person needs to log in with our identity provider. And they do a quick OAuth handshake up to the identity provider, comes back down. When we see that they've logged in, we sign a little cookie and then set it as a cookie in their browser. And then each time they make a request, we validate the cookie in the center. So this is how identity-aware proxies work. Basically, all of them have the same architecture. There's not a lot of distinguishing factors between them, but they all pretty much usually support a bunch of different identity providers over OAuth 2 or over SAML. There's a variety of different integrations between all of the identity-aware proxies and identity providers, but usually it's OAuth. And then actually configuring that, this might be hard for you to read. Let me try to point. So this is a fake internal site. So this says paste.example.com. So let's say we had an internal paste bin, something to just host documents or host text somewhere to share stuff. But the root of it says, okay, have a session duration for 24 hours. Oh, this is grayed out, really hard to see. But it says the policy name is paste, and it says deny everyone. So everybody is blocked from paste. Pretty simple. You can also say everybody in this group that is in the identity provider gets access. Everybody in a high-risk country is blocked. You can be pretty expressive with policies. You can say only these IPs are allowed if there's some IP shenanigans you still want to do. But basically, we have one of these for every internal website, which you see in the bottom right, which is 510 items for just this one account. We have more accounts, but this is the main account where you'd see a lot of these policies. So that's what it looks like in practice as somebody going in and setting this up. So that's kind of how it works for HTTP. Overview of the architecture. You configure it here, and it kind of all started with about 250 lines of Lua of all things. Okay. A big portion of securing anything these days is second factor. If you're not investing in second factor or you don't have it, that should probably be your biggest priority as a security person at your business. We wanted really strong second factor. We get really targeted phishing attacks all the time based on what we do and our sensitivity. So we basically made the decision as a company that TOTP whatever vendor, all of these second factors aren't good enough. We have to settle. We can't settle for anything less than a security key and a unfishable, because they're unfishable. And even if you make a mistake, even if you're bleary-eyed just getting off of a flight, you still can't get phished because the technology just doesn't allow you to. So we really wanted these, and we wanted them to enable, we wanted the zero trust stuff that we were building to actually enable that. Also, I would say that if you aren't super familiar with YubiKeys or you looked at them a long time ago, I think you should re-look at them if you haven't in a long time. There's been a lot of improvements over the past year or two in just the support for security keys and YubiKeys out there. iOS and Safari supported as of last December. It's supported natively in SSH now, so you can, when you generate an SSH key, when you do -T for the type of key, you can do ECDSA-SK, which means security key, one of these things. And that's really nice because then you can do two-factor auth directly in SSH, which is cool. There's the support for these is getting really, really good. And also, Face ID is a security key. All of these biometric things that are getting built into devices, they're adding support for the same WebAuthn protocol that's under the hood here. So if there's one takeaway from this talk, take a look at security keys, and if you're not doing 2FA, please work on that. Okay, so how can we actually enforce security keys and start to move away from what we had before? Actually, let me just cover this too. Before, one of the big challenges with enabling security keys was that we were limited by whatever the VPN provider supported. So you're stuck with whatever 2FA they give you integrations for, and it just wasn't open enough for us. And it was a big hassle to do anything with the VPN, managing groups, managing anything. So adding more support for second factors was a big hassle. So we just decided, let's get rid of it. And then in practice, this is what I showed you before, the architecture. Where we support security keys and where we enforce it is we make sure everybody in the identity provider sets up a security key. And that's step one. But we didn't have, when we first started introducing security keys, you're in this kind of chicken and egg problem where everybody has a two-factor authentication thing already, and then they have a security key, and you can't, if you have a big workforce, you can't just one day say, hey, the old way you used to log in doesn't work, and you have to use this new way. That does not work. So what we did was we had this kind of tandem solution where they were living side by side. We literally sent envelopes. We went to the office and we packed these envelopes with everybody. I don't know why we did this ourselves, but we packed envelopes of these YubiKeys that you just saw in every single person's envelope, and we mailed it to them. We gave every employee 2 of them, and I have one in my laptop right here. I can show you. It just lives right here, and I can touch it to log in. And then there's another one on my keychain, which is the bigger one that you just saw that works over NFC. So we gave everybody 2 security keys, and then they set them up. And then it was like, okay, well, how is this going to work where they live side by side? And that's we built a product for that. So we had this identity-aware proxy, and when you log into the identity provider, it provides a big blob of stuff back to our identity-aware proxy. It looks kind of like this. Actually, it looks exactly like this, except with real data. These are all Z's and sensitive stuff that I redacted. But the important thing is your identity provider probably would tell your proxy what type of second factor was logged in with. So you can see here, AMR means authentication method R something. Authentication method. And then it tells you the properties of that authentication method. So SWK is software key, and MFA means multi-factor authentication. And so what we did was we added support for saying that some of our applications, like that paste thing I just showed you, only were accessible if you use the security key. So when you go to log in, we messaged out, instead of saying, hey, multi-thousand person workforce, you log in only with security keys now, we said, hey, when you log into just this one application, you have to use security keys. We basically made a list of 5 or so really high sensitive applications, and that's the way we introduced it. So we said, if you log into this internal dashboard, if you log into this really sensitive thing or this other thing, you will not be able to reach it if you don't touch your security key when logging in. And that worked really well, because when you're introducing a new technology to your users, they might not be familiar with it. It took them time to set it up. Like, they all arrived in the mail at different times, and then people like put it on their counter and forgot about it for probably a month. And they really needed a reason to start using it, but they also needed some time to adjust to it. So that was a good balancing act, where we could kind of explain the sensitivity of these specific apps and also start to enforce the security keys. But that's what it looks like. This is a real assertion from the identity provider that I copied and pasted and redacted some of the stuff. And then the actual enforcement. Any Terraform users out here? I met somebody yesterday. Okay, some. This is all Terraform code. This is the cattle, not pets mentality of configuring your cloud services in code. What is it? Infrastructure as code. And this is all just a bunch of junk explaining how to set up one of those policies I was showing you earlier. But the important part is down here. It says require SWK. And that's how we actually required that you used your security key. So it's pretty simple when I go through it like that, but a lot of programming and a lot of attention to detail to build that. This is what our actual migration of WebAuthn to WebAuthn looked like. These are real metrics, and you can see, I wish I could make this like, I guess it'd have to be a mile long, but I wish I could show you like when we first introduced security keys. Excuse me. When we first introduced security keys, it didn't really take off. This blue line is WebAuthn and usage of security keys, and the red line is usage of TOTP and other forms of second factor. And at first, it was only the red line. And then we introduced the security keys, and it was like some security keys, and then we enforced those 5 applications or so, and this is kind of, it just took off, where people just got in the habit of touching it for everything, and it worked out really well, where we started with the 5, and then we added a 6th and a 7th, and we slowly expanded the set of apps that were protected by security keys, and then eventually we got to this point where we said, let's just turn off the other way. And we said, it's going away. There was like a few things that didn't support security keys. Like I think we had a problem with Salesforce and like one other thing, but that was more on us than on them. Just had to figure out how to get it working. So that was really cool. Any thoughts on security keys or questions? They're like $30 online. Cool. Yeah, so the question is, what happens when somebody loses their key? So they're required to have these hardware keys. What happens if they lose it? This happened just last week to one of our like senior directors of product or something. He calls me and he's like, Evan, I just lost my security key, and I have an important meeting tomorrow. Like I'm about to call an Uber to go to my house 3 hours away from the city and pick up my laptop to bring it. And we don't care if it's like the security key we issued you or not. So I was like, if you can get one overnighted to you from Amazon and just expense it, then we can like get you set back up, get you on a call with IT, and get you set back up. But also, we encourage everybody to add Face ID as a security key too. So last line of defense, do you have your phone? And then last is the 2 security keys. So if you have the keyring security key that you're keeping with you all the time, if you can just get a dongle, that can save you. So yeah, if you lose all your security keys, you got to get a new one, and we'll ship you one. But also Amazon will too pretty quickly if you're in a bind. But that's the only situation that I know of that's happened in the last 2 years since we rolled this out, where someone was just absolutely locked out. Yeah, so the question is, you can use Face ID. Do people prefer that versus using the security key? I would say that the security properties aren't any different. So I don't feel like we're losing any security when somebody uses Face ID, because it's still the WebAuthn thing under the hood. Whether it's Face ID, whether it's a security key, whatever. So yeah, you can also set up for the Touch ID on your MacBook or your Windows Assistant, I think it's called. You can set it up in Okta or your identity provider the same way you'd set up a security key. So a lot of devices support WebAuthn and what the YubiKeys do without needing a YubiKey. Yeah, but the security properties, in my mind, the security properties are the same. If you have FIPS requirements, you probably can't do that, but not everybody does. Okay, I gotta move on. Last, role-based access control. Excuse me. With our VPN, it was a nightmare for role-based access control because we had applications which meant that they were tied to subnets and IPs, and there's like a bunch of spreadsheets trying to keep track of where applications were and what subnets, and it just didn't work very well. I mean, you can make it work, but for us it was a big hassle. That was a big problem, but it was nice to be able, especially when the application was just a web service or something, it was way nicer to be able to just manage a group in our identity provider, hook it up to the proxy, and then say, you'll see this redacted area. You'll say, okay, this group gets access, nobody else does. So this is the Pro Dash. This is a real one that I copied and pasted today from our internal code that manages all of this stuff. The Pro Dash service, I have no idea what it is, but only this group is allowed to have access to it, and it requires a security key. So RBAC was a lot simpler to set up and manage. Pretty instant gratification there. Okay, so we talked about HTTP. That's easy stuff. How do you handle non-HTTP services like SSH and any other thing over TCP? So you run an FTP service or SFTP service. How do you authenticate that in a zero trust world if you're going to try to? And this is where we get a little mad scientisty. There's a lot less prior art here. So I talked about some open source projects, the Bitly OAuth proxy. There's a bunch that you can find identity-aware proxies off the shelf. You will be hard-pressed to find things that support. There are a few services that support SSH, but like generic TCP auth, whatever it is, there's not many. So this is the previous architecture I showed you, but with these two giant green rectangles. And so what we came up with to solve this problem of I want to SSH into a service without needing special network access. What we came up with is you run a special, here's my thing. You run a special service here on the server. We call it Cloudflare D, which connects to our edge network. You run a special service here called Cloudflare D, same one, that connects here. And then that is all over HTTP because we already solved the problem for HTTP. And then what we do is we tunnel raw TCP through this HTTP connection. It's HTTP2, so you can like actually kind of do that instead of HTTP1. But this is a tremendous hack in the sense that like this is not good software design or architecture, but it works really, really well. So we're stuck with it for forever. And it's really nice because you're able to authenticate users using all the same stuff, the groups. It's still cookie-based authentication for SSH plus your SSH key. It's all the same stuff is reusable, except now we're just sending a whole TCP connection through it and not HTTP. All of this code is open source. You can go read Cloudflare and Cloudflare D, the source code. You can go see the tremendous hack that is TCP over HTTP. It's all out there. And then the way it looks in practice, there's a lot of lines here, but there's actually two things happening. That's why there's so many lines. So the way it looks in practice, as I explained, you do the, I'll cover the bottom part. This is what your SSH config would look like when using this. And the important thing to see is you're SSHing into vm.example.com, and then when it has this proxy command thing, and proxy command is built into SSH. It's like native in the protocol, so there's no special magic here, and it will just run this Cloudflare D command here, and then proxy your entire SSH connection over that. So it might be a tremendous hack, but it's not so bad. The tooling was all there to support it, and it's pretty simple. We have a command that we tell our engineers to run, which auto-generates this because there's a bunch of like crazy percent signs and weird standard out, standard in stuff. But this is all auto-generated. Our engineers don't need to touch this. They just run like Cloudflare D SSH config generate. But that part is pretty neat. As a client, that's what it looks like. You set up this SSH config, run it. That's part one of this slide in order to get your SSH connection over HTTP. Part two of this slide is something that is special. One thing that we wanted to do, this is just more of an experiment, and it exists in the product, but it was more for fun. We wanted to support SSH certificates. So we will actually provide short-lived SSH certificates that we sign for some of our engineers when we want to give them short-lived access to a machine. And it works the same way as everything else with SSH over the HTTP connection, but there's a lot more back and forth where you're getting the certificates signed and all of that. Some prior art here is the Netflix Bless project. Netflix on their GitHub, they have a separate Skunkworks GitHub for just like crazy experiments that they do. And one of the things that they have on there is a project called Bless, B-L-E-S-S. And that is SSH certificates, almost identical to what we built here. So we kind of just copied it. Great artist steal. Cool. What? No, it's all open. Question is there a patent minefield around this stuff? The answer is definitely not. It's all SSH certificates are like in the open source software, and but I think maybe the new art that Bless did that we kind of copied was hooking up SSH certificates to an identity provider, like your Okta or your OneLogin or your Azure AD, whatever.
So is the vulnerability in this scenario still the user device? The user device is compromised, unbeknownst to them. That would still be a vector for attack.
Yeah. The question is, The question is, what's the vulnerability here? The device is compromised, and is that it? Like, is that the risk scenario? And the answer is yes. Let me advance the slide. Okay, so this is how we, if you read the Beyond Court papers, which I called out earlier, 2 of the 6, if you go to any zero trust vendor and they offer you an identity or a proxy, ask about their device identity solution. 2 of the 6 Beyond Court papers are about device identity and authenticating like the device is one that you own. And that's a major tenet of what Google originally wrote about, and it seems like a lot of vendors just forgot about that, or they didn't read the papers. But the way we're doing this is on all the client machines on the left, we started installing WireGuard clients, which WireGuard is a protocol that is supposed to replace OpenVPN, made by this guy named Jason Donenfeld, and it has support in the mainline Linux kernel, which is great, but it's supposed to, I mean, the big gripe with OpenVPN is it's like 150,000 lines of code and nobody's ever read it, and WireGuard is supposed to be like, it's 2,000 lines of code. It's a lot simpler. So we started installing all of these clients on our corporate machines that basically send all the traffic to our server. And we have in the back end, a mapping of like WireGuard public key, because part of the authentication process for WireGuard is you present your public key. We have that along with your device serial number, and then your name, your email address, so we know when you're connecting with your actual device, and that's part 1 of device identity. But that's the WireGuard portion. Part 2, Beyond Corp, yes, I covered that. Part 2 is we actually started putting certificates, the traditional PKI route. We started putting certificates directly in people's browsers and enforcing that people have those certificates when they hit our machines. So just like our Edge enforces that you have a cookie that says who you are, we also enforce that you're doing mutually authenticated TLS between your client and server. And actually, we're in the phase of dialing the pressure up right now. Just like we did the security keys 2 years ago, where we started dialing up the pressure and enforcing people have their security key when logging in. Right now, we're in the phase of we just pushed out the certificates, and we're just trying them out on a few websites internally that we enforce the certificates for. So those are the 2 ways we're addressing the, actually there's a 3rd way I forgot about. There's also all these other device signals. I don't think that our core competency is the like endpoint protection. That's not something that we're gonna get into. We're really good network people. We're really good like real-time services people and distributed systems engineers. So we started like integrating with some of these people who are good at endpoint protection, and like for me, all I care about is like full disk encryption is turned on. They're running our software, like the process list has our software that we mandate is running, and then there might be another one like passcode. You're enforcing a password. Like I only care about really basic security controls, but integrating with some of these that can tell you, okay, there's not viruses or anything is a value add. But that's not really my wheelhouse. But those are the 3 ways we're kind of addressing the device identity stuff internally. Okay, the last is the real crazy experimentation stuff that we're doing right now. This is like pure mad scientist stuff. So I think it's really cool, but it's not really well used internally yet. It's still got some rough edges, but I think there's a lot of hope in this space. The first is called Zero Trust Apps, which we're building. We have a whole blog post about it. You can go search it and read it, and they have like nice GIFs and stuff which show this. But you'll notice this is in a browser. So this is an SSH thing in a browser. If you've ever used Google Cloud's like VM thing, you can press a button and it'll give you an SSH connection in a browser. And if you're ever like, how does that work? I'll tell you, I don't know how theirs works, but I know how ours works. And what we did was we took the SSH client and compiled it to WebAssembly and then sent all the connections over a WebSocket and then treated everything the same way. So instead of having to deal with all of these really weird protocols, like I was explaining all the challenges with SSH, we just put it all in a WebSocket, run it in WebAssembly in a browser, and it seems to kind of work. There's a lot of details there and that are very specific to each individual application. And I think it took somebody like 2 weeks to get this running, and it's still kind of new and experimental, but it's promising and it does work. Like you can actually go try this out for free. It doesn't cost anything to use these products, and set it up and give it a try. That's one area. And then another is we acquired a company last January called S2 Systems, and they do remote browser stuff. And this is like a real version of Chrome that we run on our edge. And so we started integrating that with our products, where we can actually enforce that for our super sensitive, high sensitivity apps. It's in a browser that's not running on your machine. You access this browser just like you go to any other web URL. We intercept it and then run the browser in the back end and then render what you're seeing on your machine. So this is still experimental for the most part. It's real and runs on our edge, and like it's really cool and actually works very well. Internally, we're using this because we're still shaving a lot of the rough edges off. We use it for all news sites. So you go to like CNN or whatever news site, New York Times, and it renders in this remote browser, and it's pretty neat, but we're not incorporating it into our security model. I can imagine a future where we do, and we make sure that before you download a PDF or maybe we block drive-by malvertising or whatever types of things we want to do. It just gives us a lot of control having the entire browser be ours. So that's kind of experimental stuff. And this isn't like headless Chrome. This is like full Chrome. This is like real Chrome that we just run on our edge. It's kind of nutty, but it works. Okay, that's all I had for you. There's a lot of content here. If you have any questions or whatever, I'll be around. But my email is evan@cloudflare.com. I hope you have a good idea around some of the problems associated with moving to zero trust and some of the ways you can address them, and the technology. Like you don't have to figure it all out on your own, and you can investigate in some prior art. But the main parts of zero trust, the main tenets you need to be successful, is you need to solve the HTTP problem, the non-HTTP problem, and then you need strong device identity. And yeah, if you can solve those three things, then you're good to go. And check out Security Keys if you haven't, because the support has become really amazing in the last 2 years. That's all I had. Any questions? Or
So around role-based, and the same with larger organizations, 100,000 plus, there's a variety of different roles. It seems like it's only as good as the role, like you assign these groups are allowed to go to it. People change roles, no longer need access to it. What do you guys do or recommend for cleaning up those, or do you guys, periodically scan up, hey, this user's part of this group and never visited these pages? Do they need to be removed?
yeah, the question is, what do you do for role-based access control in like a massive organization? We're not a massive organization, so we can actually like hand groom groups, and I'll usually tell people, you're in charge of this group, like this is your responsibility, and then it's theirs. There's a lot of, I think that there's not a lot of public prior art on this problem though. Like I know that some companies have implemented things where they see if I make a group change and it affects more than 10% of the workforce, or they have thresholds in there where they test their changes before making them and have some like basically unit tests for what is and is not a good group change. And then maintaining those is hard. Like you have to do it by the org chart, by the region, by the app sensitivity, but you end up with like all of these circles and patchwork of security requirements for each app, and it's hard. So I don't have answers for you. That's a hard problem. Okay.